Look at your hand right now. Actually do it. Curl your fingers into a fist, then open them again. That motion, the grip, the release, the precision of it might be one of the biggest reasons you're capable of thinking the way you do at all. Not your brain size, not some single evolutionary leap. Your hand. For decades, the story of human intelligence has been simple. Our brains got bigger, and everything else followed. Tools, language, culture, all downstream of a growing brain. But that story has a problem. It doesn't explain why the brain grew in the first place, and a growing body of research suggests the answer might be sitting at the end of your arm. Here's where it starts. Around 2.6 million years ago, in what's now Ethiopia, hominins began doing something no animal had done before. Not using objects as tools. Chimpanzees do that, crows do that. What early humans did was different. They deliberately struck one stone against another at a precise angle to shear off a sharp flake, on purpose, repeatably. Archaeologists call this technique napping, and the earliest known examples, a toolkit called the Old One Industry, represent the first solid evidence of intentional toolmaking in the human lineage. Some finds may push this even earlier. Stone tools discovered at a site called Lomakwi in Kenya have been dated to roughly 3.3 million years ago, potentially before our own genus Homo even existed. If that dating holds up, it means tool use didn't wait for bigger brains to show up first. It may have started the process. That sounds simple. It isn't. To nap a stone, you need to hold the core rock steady with one hand while striking it at exactly the right angle with the other. Too shallow, and the flake won't separate. Too steep, and you shatter the whole thing. You need to predict before you strike exactly how the stone will break, which means holding a mental model of an object's internal structure in your head and translating that model into a precise physical motion over and over, adjusting each time based on how the last strike landed. That's not simple hand-eye coordination. That's planning, sequencing, cause and effect, played out physically, one strike at a time. And here's the part that should make you sit up. When researchers scan the brains of modern volunteers learning to nap stone tools the same way our ancestors did, the regions that light up aren't just the ones controlling hand movement. They overlap significantly with regions involved in language processing, including areas right next to Broca's area, one of the two major language centers in your brain. Let that sit for a second. The physical act of shaping a rock with your hands activates brain circuitry sitting right next door to the circuitry you use to form sentences. That's not a coincidence researchers are comfortable ignoring. The leading theory goes like this. As early hominins got better at precise, planned hand movements, striking, gripping, shaping, the brain regions responsible for that control had to get more sophisticated. More sophisticated motor planning meant more neurons, more connections, more capacity for sequencing complex actions. And that same expanded capacity for sequencing physical actions may have been repurposed over evolutionary time for sequencing something else entirely. Words, grammar, syntax, the order you put ideas in. In other words, your ability to plan out a sentence and your ancestors' ability to plan out a stone strike might share the same evolutionary root system. This is sometimes called the gesture-first theory of language. Some researchers argue that before humans ever spoke complex language, they communicated with precise hand gestures, the same fine motor control used for toolmaking, repurposed for pointing, signaling, showing. Vocal language in this view came later, layered on top of a communication system your hands built first. There's modern evidence that backs this up in a strange, direct way. Sign languages, full complex languages used by deaf communities around the world, aren't simplified pantomime. They have their own grammar, their own syntax, their own poetry. And brain imaging studies on fluent signers show something remarkable. The same core language regions that light up when a hearing person speaks a sentence also light up when a deaf person signs one. Broca's area doesn't care whether language comes out of your mouth or your hands. It treats them as the same kind of task. That's a strong hint that language itself was never really verbal at its core. It's structural, sequential, a system for ordering meaning. And your hands are just as capable of running that system as your voice is. This connects to something cognitive scientists call embodied cognition, the idea that abstract thought isn't something that floats free in your head, disconnected from your body. It's built on top of physical experience. Think about the language you already use without noticing it. You grasp an idea, you handle a problem, you say something is within your grip, or that a plan fell apart. That's not poetic coincidence. Some researchers argue your brain genuinely borrows the neural machinery for physical grasping when you're mentally grasping a concept. You learn to physically hold objects long before you learn to hold ideas, and your brain may never have built a fully separate system for the second one. It just repurposed the first. Now, I want to be honest with you about something, because this is where a lot of pop science content oversells the story. Nobody is claiming your hand alone created consciousness. Consciousness itself is one of the hardest things in science to even define, let alone trace to a single cause. What researchers actually argue is something more interesting than a single clean answer. It's a feedback loop. Better hands demanded a better brain to control them. A better brain made more complex tools possible. More complex tools demanded even more precise hand control. Each side of that loop pushed the other forward, generation after generation, for over 2 million years. It's not hands made you conscious. It's your hands and your mind built each other, one small improvement at a time, for longer than anything else in your evolutionary history. And there's evidence this loop left a permanent physical mark on your actual anatomy, one you can basically see mapped out. In the 1930s, a neurosurgeon named Wilder Penfield was operating on patients for severe epilepsy, and to avoid damaging critical brain regions, he'd touch different points on the exposed surface of a patient's brain with a small electrode while the patient, fully conscious, described what they felt. Touch this spot, the patient's thumb twitches. Touch that spot, they feel a sensation in their lips. Strip by strip, Penfield mapped which parts of the brain's surface controlled which parts of the body. What he found was strange. The map wasn't proportional to body size at all if brain space were assigned the way you'd expect. Based on how much surface area a body part actually covers, your back and torso would dominate the map, and your hands would get a tiny corner. Instead, the opposite happened. The region controlling your hand, especially your thumb and fingers, was enormous. So was the region controlling your lips and tongue. Meanwhile, your entire torso, most of your actual physical body, got a sliver. Scientists sometimes visualize this as a distorted human figure, drawn with body part sized according to how much brain space they command instead of how much physical space they take up. It's called a cortical homunculus, and it looks almost cartoonish, grotesquely oversized hands and lips on a shrunken little body. But it's not a joke. It's a literal physical record of what your brain considers worth the investment. And your hands are near the very top of that list, alongside the mouth parts you use to speak. So next time you pick up a pen, type a message, or just gesture while you talk, you're activating some of the exact same neural machinery your ancestors used 2 million years ago to strike stone into blades. The wiring didn't disappear. It just found new jobs. There's a strange twist to end on. Some researchers now argue this loop isn't finished, that it's still actively running inside you today. Every time you learn a new fine motor skill as an adult, learning an instrument, learning to type quickly, even learning sign language from scratch, brain scans show measurable growth and reorganization in exactly the motor and language-adjacent regions we've been talking about. Your brain doesn't fully distinguish between physically shaping an object and shaping an idea. As far as your neurons are concerned, they might be running closer to the same process than you'd ever guess. We like to imagine intelligence as something that happens purely in our heads, an invisible, abstract process floating somewhere behind our eyes, disconnected from the rest of us. But for most of human history, thinking and making were the same motion. You didn't think, then act. You thought through your hands. 2.6 million years later, you're still doing it. You just don't usually notice.